Hello SpaceX fans, we are back with another video for you to quench your thirst for all things space. So buckle right in, because we are going on a flight to the stars. But before we move on, make sure to press the subscribe button and do not forget to hit the bell icon to never miss out on any of our latest space niche videos. In this video, we will be talking about how Tesla has shattered all rules and established industry standards when it comes to making a computer. Though you might not be able to kick back and relax in a completely autonomous vehicle today, automakers all over the world are racing to place one on the market. The techno king of Tesla might be the most eager to do so. From the time they hit the mass market nearly a decade ago, Tesla's vehicles have garnered reputations as iPhones on wheels. A revolutionary technological leap that did for cars what Apple smartphones did for consumer tech. They offered large touchscreens, a vast charging network, and groundbreaking performance that delivers on the dream of electrification seemingly without compromise, where the competing products failed to stitch all aspects of that formula into one. Like Apple, Tesla built its brand on exclusivity and aspirational products, prioritizing the experience of ownership as much as the utility of the device itself. And both companies have integrated software with hardware in a way that revolutionized their particular industries, making the transition to new technologies relatively intuitive for even the most non-tech savvy user. Elon Musk has recently supercharged Tesla's self-driving artificial intelligence technology with a powerful new supercomputer, which he expects will drive his Teslas to the finish line at full throttle without human supervision. In this deep dive, we scrutinize and explain everything Tesla has said about computer hardware and compare it to the competition and the way things are normally done. In June 2021, Andrej Karpathy gave a talk on the strategy of Tesla towards full self-driving cars. He detailed the specifications of their latest and largest cluster for neural network training and testing. The cluster consists of 720 nodes of 8 NVIDIA A100 GPUs each, making up 1.8 EFLOPS at FP16 in total. In terms of flops, it would rank 5th supercomputer in the world. This worked out for Tesla until now. On the one hand, they didn't really want to rely on other companies' chips anymore. And on the other hand, NVIDIA GPUs aren't specifically designed to handle machine learning training, which makes them relatively inefficient for the task. GPUs were the best option until the AI industry grew so large that it became profitable to build specific hardware. Tesla decided to follow the trend and start building their chips and eventually a supercomputer. Following the principle of vertical integration, they wanted to design and manufacture their hardware in-house, and so Project Dojo was born. The heart of the design is the Dojo D1 chip, which provides stunning bandwidth and computer performance. Tesla found existing computer platforms lacking from their primary problem to solve, developing self-driving technology by training its massive neural networks. But they also hinted they might provide Dojo to other developing AIs in the future. Tesla's motivation for Dojo springs from a massive amount of video data captured from over their large fleet of existing vehicles, which it uses to train its neural nets. Tesla was not satisfied with other HPC high-performance computing options for training its computer vision neural nets and decided they could create a better platform. Tesla's goal with Dojo is to achieve best AI training performances, enable larger and more complex neural net models, power efficient and cost-effective computing. This means Dojo isn't necessarily intended to be more powerful or faster than the GPU cluster they already have. Neither do they want it to compete with the most powerful generic supercomputers out there. The main criterion is to make a computer that is better at doing AI than any other, so they don't need to use GPUs ever again in the future. A common factor when building a supercomputer is how to find a compromise solution between scaling computer power while at the same time keeping high bandwidth and low latencies. They found their answer in a distributed 2D architecture composed of robust chips and a unique network fabric, allowing for fast communication, high bandwidth, and low latencies. Loyal to their principle of vertical integration, they wanted to build themselves the elements at almost every level from the bottom up, from the training mode, comprising the smallest computing elements, to the D1 chip, to the training tile, their unit of scale, to the exapod, the cluster that would eventually replace their GPU stack. Tesla's meme lord needs all this computing juice to power both the interior and exterior of his fleet of self-driving cars. On the inside, Tesla needs powerful computers to run its autonomous driving software. On the outside, it requires massive supercomputers to train its self-driving software. 8 surround cameras, each running at 36 frames per second, are mounted on each Tesla vehicle to provide 360 degrees of visibility around the car at up to 250 meters of range. The vehicle's advanced driver assistance system, imaginatively called autopilot, gathers information from all Tesla vehicles on the road and feeds it to the brains built in the car, where they study this data and make predictions to improve autopilot's driving performance. At the same time, this mountain of data is shared on Tesla's neural network to determine if the driving decisions made were accurate, or if any data was misinterpreted. In an event where the data was indeed misidentified, it will then continuously run through supercomputers to tweak its behavior, which effectively trains the ever-improving autopilot AI model. We have a neural net architecture network, and we have a dataset, a 1.5 petabytes dataset that requires a huge amount of computing. So I wanted to give a plug to this insane computer that we are building and using for now. For us, computer vision is the bread and butter of what we do and what enables autopilot. And for that to work really well, we need to master the data from the fleet, train massive neural nets, and experiment a lot. So we invested a lot into the computing, commented Karpathy during the conference. But training computers to understand roads, even with cameras and LiDAR on board, is difficult, involving innumerable contingencies and bizarre scenarios that impede the vehicle's ability to process its surroundings in a traditional manner. With this, we have come to the end of the video. Congrats on having such a great attention span. Let us know how excited you are about the new ventures of Elon Musk and Tesla down in the comments below. Thank you for watching, and if you enjoyed the video, make sure to like and subscribe for similar content. Until we meet next time.